Yeah, let me just, Adika, sorry. Okay, thought you had your hand up. So we're just going to take it away, guys. Today is our day 6 of the training. And before I proceed with this presentation, that is the slide presentation, I'm just going to, because today we're going to write a smart contract and basically talk about a smart contract here. So I'm going to leave that project sort of being initialized as I proceed with it, so that we don't waste time doing that later. So let me just navigate to the project, the directory we're going to work from. Okay. Yes, so right here. So I'm simply going to open this up in my terminal. Then I'm going to share this. So I really hope you guys can see my screen. So right here, we're going to see how we can create a near smart contract project in Rust. Okay. So now you should be having Node installed within your machine. You should have Rust installed within your machine. You should have the web assembly toolchain, Rust toolchain installed as well. That is what is going to help us compile our smart contracts into the WebAssembly file that we're going to use. So for you to sort of set up your project, this is how you go about it. You write npx, sorry guys for the background noise. So that is basically the command you're going to use, npx create near app. Then you give you specify the contract that you're going to use. In this case, you're going to use the Rust programming language to write our smart contracts. So we specify our contract as we give it a value of Rust. Then the name of our project. In this case, we're going to name it demo. So basically going to give it that very basic name. So I hit on enter, and you wait for that to sort of do its thing in the background. So let me press yes to proceed. So I'll just leave that to do its thing in the background, and we'll come back to that later. So for now, we're going to proceed with our presentation right here. Now, yeah, this is our day 6, and we're going to talk about smart contract. Basically some few concepts when it comes to writing smart contracts in Rust. And a reminder, if you don't have an idea you're going to implement as your demo project, please ensure you do so and start working on it as soon as possible, or as soon as you feel comfortable to start. Then here are some of the tools you need to have for you to proceed with this session. You need to install Rust, you need to install Cargo, you need to have the Rust, the WebAssembly tool that is going to help us compile our Rust source code into WebAssembly bytecode or binary file. You need near CLI installed, that is an a node package. Then you also need a testnet account, as we did in our previous session yesterday. Now, here are some of the concepts we're actually going to cover during this session. We're going to walk through a very simple smart contract code, in this case, just to give us an idea on how things are really happening in the smart contract development. Then we're going to talk about a Rust module that is specifically going to sort of give us a blockchain interface. So in this case, we're going to do some blockchain specific tasks within our smart contract. And some of these tasks, or some of these things we can do with this module, the ENV module in this case, are listed down here, the account balance, account lock balance, and all that. So we're going to basically look at all that. And the list continues to this other slide. So we're going to talk about some of these functions, and we're going to talk about them in details on what they do and probably when you can use them. So let's get these. Done. Someone has a question in the chat. Okay, yeah. I'll share that with you. I'll just attach it to the video as you upload it on YouTube. So you realize my project is still being initialized. So let's just hope this happens as fast as possible. We don't want this to take our time, really. Maybe as we do that, I can copy the requirements in the chat for some of us to start off with. So let me just share a link. I think that will be even easier. So near docs, they should be able to do it. Let's see what this does. Here. Awesome. Yeah, so those of us who don't have the tools I just talked about, maybe you can just follow the link I'm going to share in the chat and see if you can get up to speed to retrieving them and setting up everything. So just follow that link and all the information will be available at that page. Let me see if our installation was successful. Awesome. So this was successful, and our demo project was created right there. So I'm basically going to seed into that. So first of all, I clear, then I'm going to seed into our demo directory. So this way we're going to have our, let me just open this up in our favorite code editor. Okay, so Destiny, here is the command I used, npx create near app. Then you specify the control or the programming language you're going to use, in this case, Rust. And our project name was demo. So that is the command, Destiny. I really hope you've seen that. So at this point, I'm going to share the code editor. And this is what is basically going to help us. We're going to, let's have a look at what was created for us out of the box. Now, you look at this folder or the directory that was created by running that command. We have the contract folder. Now, for the better part of this session, we're going to work from this particular directory. Then we also have the source or SRC folder. Now, if we are going to do our front end, we will do it from this point. But for today, we're not going to touch on that. Then we also have the node modules directory in case we're going to need any node modules in that case. And we have the near dev, so all our dev credentials in case we're going to use this particular directory are all going to be stored right here. So for now, I just wanted to show us the whole sort of folder arrangement within that project. But since we're going to work from our contract directory, I'll just cd into that particular directory and fire it up in my editor. So I'll just go ahead and close this, or let me just first cd into that particular directory, then launch my code editor from that point. So that should be able to launch our code editor. Okay. So let me hope that is going to work. Great. So I just launched. So like I said, guys, maybe I can cancel this first. So like I said, we're going to work from this folder, the contract folder, and I've just opened that in my code editor, and that is what I'm going to share. So I hope it's that. Yeah. So there we go. So I'll just go ahead and close what I shared initially, and we're going to work from this folder now. Now, right in this folder, we also have quite a number of files and directories. So all these files are just for project setup that are going to help us achieve our smart contract development, compilation, testing, and all that. Now, from this folder, we're going to work from our source folder, the SRC folder. It contains one file, lib.rs. And like I said, by running that command, it created for us a library, a Rust library project. So that's why we have lib.rs instead of main.rs as in our previous sessions, okay? So this is the file we're going to work from. Then we also have these other directories that I won't talk about for now. We at least know what is going to happen in our target folder or directory. So this is where we're going to have our build file stored. Of course, we're going to see how that is going to happen. So let's dive in our lib.rs file. I just increased the font for those of us who may not be seeing something well. Okay. So, oh God, how can I do this? Okay. So this is a file. You realize there's a boilerplate code that has been put in place already for us that we can work with together with some tests. Now, to get us started, I'll just do away with this particular code, or rather we're going to edit it, okay? So let me just do something, some hack in the background. Okay, so we're gonna compress this. Then, yeah, so I just compressed that. That is in case we may want to get back to the content of this file. So I'll just have it backed up somewhere where unfortunately you guys may not be able to see. Okay. Awesome. Now back to our file. So we're going to talk about the content of this file. And like I said, we're basically going to sort of replace the whole of these data right here, right? So we can as well go ahead and delete everything and start from scratch. Now, we're going to implement a very basic smart contract code that we're going to basically walk through as we proceed with this particular session. So we're going to create a counter. Our smart contract is basically going to be a counter. So in this case, we can increment, decrement a value, and yeah, all that. Now, to get us started, we're going to create a public structure or a public struct. In this case, we're going to call it a counter. Our public structure or struct, in this case, a public class, like I said in our previous session, I'll be referring to this struct keyword as a class for us to get the concept quite easier. For us to be able to sort of compile these to a WebAssembly binary file, okay, we're going to need a macro that Nia has availed to us that is going to sort of help us achieve that particular functionality. And this is how we use that. It's called Nia bindgen. Okay. So by using this, you realize it imported it from Nia SDK. Okay. So Nia bindgen is basically a macro that is going to facilitate compilation of our code or our smart contract code into a WebAssembly binary file that is going to be compatible with the Nia blockchain. The other macro that is available to us is derive, and this is basically going to help us serialize and deserialize our file. So basically, our code and any storage functionality we have within our smart contract. So anytime we want to execute our smart contract on blockchain, it will be easier because then these will ensure that that happens easily. So I'll just add a Bosch, should be Bosch serialize and deserialize. Sorry, serialize. Awesome. So I have those in place, and they were imported as well from near SDK. Then the other thing I'm going to do in this case, okay, I hope that is going to go away. We're going to define an instance variable. In this case, we're just going to use a value, okay? So this value is going to be, we don't want our counter to go below 0, right? So 0 should be the minimum value. So in this case, we're going to use let's use U32, okay? Yes, U32. Then we're going to implement our structure. So there's what we call the default. So this is basically going to help us sort of bootstrap our counter class or counter structure for counter. And yeah. So here we can basically have a default function that is going to return self. And in this case, we can basically return that value, the value of self as 0. Yeah. Okay. Oh yeah. So we're going to return an object. I think I forgot this self. Yeah. 0. Yeah, so that is it. Then the other thing, I don't understand why this is not working. So the other thing we're going to do is we're going to implement now methods to our counter class. So to do that, we're basically going to have a method that is going to, so the very first thing you want to do right here is to give some default values. Sorry, to increment or decrement our value, okay? So since this is a counter, we're going to basically change or play around with the val, or we can call this value of our counter, okay? So the very first method we can have in this is going to be, let's first read the value, okay? So we can say read value. So read value is going to be a method of our counter class. So we're going to take a reference to the self object. If you're coming from Python, that should be you should be familiar with that. And it's basically going to return a value of type U32. And we return that by doing self dot value. Okay. So that is basically how we go about that. Then to read, we're also going to see how we can sort of read our value. So to basically do that, just a minute, guys. To basically do that, sorry, we're going to decrement a value. So we're going to have a function. We're going to call it something. What else? What should we call it? Okay, let's call this decrease or decrement, right? It's also going to be a method of this class. So it's going to, now since we're going to change the value of our counter class, we're going to get a mutable instance of our class or our object. And we're basically going to decrement that value. So in this case, you're going to do self dot value minus equals, or yeah, so in this case we're basically subtracting 1 from whatever we have in our self.value. Okay. So the very first thing we can do in this at this point is to check if our value, in this case self.value, is greater than 0. Yeah. So we can check if that is greater than 0. So if it is, then we can go ahead and do what? Subtract 1 from the value. Okay. Else, we just leave everything as it is. Okay. So that we don't raise any error within our function. Now, the other function we're going to have in this place is going to increment. So in this case, we're basically going to increment its value. And as this, to achieve this, we still have to change the state of our counter class. So in this case, we're going to take a mutable instance of our object. Okay. So right here, after decrementing the value, we can basically return that value so that we are able to have some response of what happened after sort of executing that function. So in this case, we're going to return a value of type U32. And right down here, we basically return that particular value. So that should be it. So right down here, we're going to increment that value. So to achieve that, we basically do self.value. And we're going to add 1 to whatever we have. So in this case, any value that is going to be at our value instance variable is going to, we're going to add 1 to it. Then after doing that, we're basically going to have a return type of type U32 and basically return that value to after running or executing this particular function. So that's how we're going to achieve that. So that is, we are able to read the value, we are able to decrement the value, we are able to increase the value. Okay. So that's a very basic counter smart contract we just came up with. So I'm also going to have to use a near bindgen right on top there and also somewhere down here. So these are basically going to help us compile down our smart contract into WebAssembly in a manner that is going to be very compatible to the near blockchain. So that's why we're really going to use or have to use these macros. So these are particularly availed by the near team in this case. So yes. Okay. So back to our file. These functions now, I don't know if someone can remember, but then when we were talking about functions in Rust, we said that both the functions and the variables in Rust programming language are private by default, okay? So in this case, all the functions we've written right here are private. So for us to make them public, then we'll have to sort of prefix them with a pub keyword for us to make them public or for us to be able to execute them outside the scope of this particular class. So that is all we need to do there. Then I'll just do a simple hack up here to see if this is really going to help us address this challenge. So I guess I need to import this as well. So we can just import that. Okay. This error is not still persistent here. And how I should go about this. Let me see if I import it. Otherwise, we'll be able to address this particular error right here, guys. So that seemed to do the magic. Can just do away with that for now. So importing near bindgen from the near SDK, then this function, and we also bringing in these modules from near SDK Bosch package or module in that case. So our smart contract is good to go. So that is basically the code for our smart contract. Now, I'm not going to write the test for now. We'll be talking about test later. But for now, I just want us to see if you can go ahead, compile or build this particular smart contract, deploy it to a testnet network, and be able to invoke these functions so that we're able to see if actually something is happening. Okay. Now, something to note with these functions, and maybe if I can do some documentation to these functions, the read value is going to be a view function. Guys, you realize in our previous, I think it was yesterday, in our previous session, I talked about call functions and view functions. Now, view functions has nothing to do with the state of the blockchain. So they don't change the state of the blockchain. And there are some concepts we're also going to cover. They have nothing to do with those sort of tasks we'll be looking at. Now, if you're going to perform any, like in this case, we're basically reading the value of the blockchain. So like self value. So in this case, we just need to get that particular value. So there's nothing else we are doing. So in that case, this is going to be a view function, and a view function means you can run it without signing it or attaching your wallet address to it. Okay. So you basically run it as it is without attaching your wallet address. However, these other functions, the decrement and increment function. So these are view function. Let me just note that up there. So it's basically reading the state. Let's call it the state of blockchain for now. Then the decrement functions, on the other hand, is going to be a call function. So a call function is going to sort of it is going to write or change the state of the blockchain. So in this case, we're going to change our value by decrementing its value, or the value stored there. So in that case, you are changing the state. So in that case, this function becomes a call function. So we sort of have to sign it, okay? So this one changes the state. Sorry. Then same thing to our increment. Maybe if I can just copy this down here for the sake of time. Yeah, so they should be doing the same thing. So that is a simple, a very naive smart contract we have, okay? In real world, this may not really have a use case, I doubt. But that is the contract we have for now. So right here, we're going to, I'm simply going to come up with a, not there, guys, but I'm going to come up with a directory. Now, we know how to perform these commands from a terminal, okay? But to make work easier, we're just going to come up with some scripts that are basically going to help us do this as fast as possible, so that we also don't take a lot of time doing this, okay? So the very first thing we're going to do is build our smart contract, okay? And if you can remember this command from our previous sessions, it was cargo build, okay? It should be cargo build. Then our target folder is going to be the WASM, I think it was WASM 32, unknown, right? /release. Yeah. So let me just give the exact notation to this right here. Okay. So I'm just getting the whole, it's quite a bunch of commands. So, sorry, right there. So we're doing cargo build, then we pass in the all flag, and then we're specifying the target. So our target, in this case, we're specifying it to be, you realize I told us to install this particular tool. So this is what is going to help us sort of compile that down to a WebAssembly file, okay? Then we're doing a release. So instead of doing a debug or something that is not ready for production, in this case, we're just simply specifying that, hey, make it ready for production because we're going to push this to a testnet network. Then that is going to be availed within our target and WASM32 unknown folder. So we're basically going to copy that from wherever it is going to be compiled down to, and we're going to make it easily available to our reach. So we're basically going to copy it to this particular folder. Okay, so that is the whole operation that is going to happen after when we run this build script file, right? Now, we'll just go ahead and run this file for now so that we see what's going on before we proceed. So I just launched my terminal. So the very first thing I'm going to do, since I'm on Linux, I'm going to grant this script file permission to run these commands, okay? So to do that, I'm basically going to do achieve that by doing this. So I'm basically granting all my scripts file under the scripts folder to run the commands that they are holding or they have. So that was successful. So I can basically go ahead and run my scripts. So in this case, scripts build.sh, and that should go ahead and build our smart contract source code into a WebAssembly binary file. Copy it from this particular folder. You realize it has been created. So this is the folder I was talking about, and the release, and our smart contract binary file should be somewhere here. So it is basically going to, after building it, of course, it's going to copy it from this point to this directory, the resource directory up here. So that might take a while, but let's just hope it's going to work well. Gonna take a while. So maybe as that runs, let's talk about a question from the chat. Yeah, Daramola, you're right. We needed the Bosch module, so we needed to get it from the Bosch module. How do we link it with the front end? We're going, Sharon, we're going to look at that. Yeah, it should be a session we're going to have next week. So we're actually on our third topic. If you look at the list of topics that were shared with you during the invitation to the course, we had about 6 topics we're going to talk about. So we are currently on the third topic. So the front end bit I think it should be the 5th item we're going to look at, and that is going to come in next week. So just hold on. We're going to look at that in time. Let me see if these so our build was not successful. So we are told that the trait counter serialized is not satisfied. It's not implemented for the counter. Okay, let me see what's the issue, what the issue could be right here. So we have this over there. And we have all these over here. Okay. So let's do this again. Let's try doing this again. Yeah, so that was done. So in this case, you realize that our file is called greeter.wasm. Now this name greeter doesn't match what you have or whatever we're working on. The name was taken from our cargo.toml file right here. So the name of this package was greeter. So I'll just change this to counter, and that should be able to fix the naming in the naming of our binary file. So I'll just redo the build, and that awesome. So that just created a counter.wasm file for us. So this is what we're going to deploy to blockchain, guys, right? This is the file we're going to deploy to blockchain. And if you're in our session yesterday, you should be able to know how to do this, how to deploy a file to blockchain. Now, I'll just proceed from this terminal right here. Maybe if I just clear that out. So yesterday we created a sub account to the account we created, the testnet wallet address we created yesterday. That is wajakoya.testnet account, right? Then we had a sub account test.wajakoya.testnet account. So that is basically what we're going to use. And let's see if that is going to help us out. So I'm just going to add another script file right here that is going to help us achieve that. So other than build script, you're going to have deploy.sh script. This is very important before we proceed. So for us to deploy a smart contract, the very first thing we need to do is ensure that our sub account is in place. So the very first thing we're going to do, or the very first command we're going to run, is to delete the account if it exists. So near delete test.wajakoya.testnet. And our beneficiary account is going to be wajakoya.testnet. After deleting that particular account, the next command we want to run is near create account. And this one is going to create a test.wajakoya.testnet. And the master account to this sub account is going to be wajakoya.testnet. Okay, so that is the wallet address we created yesterday. So that is basically how we're going to go about. So those are some sort of initial steps to take while redeploying your smart contract. Now you realize I'm deleting the account first, then recreating it. In this case, in case you're going to interfere or make any change to a blockchain state. So instead of to avoid the errors that might come, we just do away the account itself, then redo it again. So after that, I'm simply going to deploy now my my wasm file. So near deploy, we're going to deploy to test.wajakoya.testnet. That is what we're going to do. And our wasm file path is going to be provided as res/, we called it counter.wasm. So that is basically what you have in this folder, guys. So this should not confuse you, counter.wasm right there. So that is basically the path I've provided over there. Saving, okay, I need to grant permission to that file I just created. So that is what I just did. Then I'm going to simply run the deploy script file. So that should be able to do the magic for us. Instead of writing these commands in our terminal, one after the other, it is just going to do it at a go for us, so that we just wait for the results. I think that is going to be efficient for our development. So let's see what that is going to do. Yeah, so account was created. It is now deploying to account test.wajakoya.testnet, and boom, that was done successfully as indicated down here. Now, what we want to do after deploying our smart contract is to test the functions we wrote, or try to invoke the functions in our smart contract and see the behavior. Okay, So I'll just clear my terminal for now. Then I'll go ahead and you remember in our smart contract, we have these functions, the read value, decrement, and increment functions. Okay, so those are the three functions we're going to interact with in our smart contract. So right here, I'm going to add another script file in this one. I'm going to call script file, and I'm going to do the due diligence to it as well to qualify it as a script file. Then we're going to call, the very first thing we're going to do is view, call a view function. Okay, so in this case, near view, passing in the account where we deployed our smart contract. So what is the account where we deployed our smart contract? Test.wajakoya.testnet. So that is the account name. And what is the function we are trying to invoke in this case? Let's get back to our source code. So we're going to invoke read value, right? So that is basically what we passed there. And like I said, it's a view function. So by this command up to that point should be able to run successfully. However, we definitely have to prove this by running it, by actually running it. So the very first thing you're going to do is grant it some permission, then run the script file. I called it call. And let's see what that is going to display. Awesome. So you realize we have the value 0. Okay. So the value 0 from what we read. So this value 0 was returned to us from our smart contract. Now, if you're here and maybe you want to prove this, if you're now oh, okay, somewhere like, yeah, I've got it. Now, if you're here and you want to prove these allegations, right? Just go ahead and I've pasted the command in the chat. So if you have near CLI installed within your machine, just go ahead and run that particular command and let us know what you get. Okay, so you can, while you respond in the chat, you can just put there a read value, colon, the value you got. Okay, that will help us prove what's going on, because you should be able to do this from your end as well. It's now online. Our smart contract is now on the blockchain. Okay, now we're going to run another command. In this case, I can just comment that out, guys, for now. So we're going to run a call function, and in this case, we're going to call a function, sorry, that is in a smart contract deployed at this account ID, test.wajakoya. And the function we're going to call is an increment. We're going to start with increment. Okay, so increment function. So that is what I just specified right there. It is not taking any parameters, so our JSON object can just go empty. But then we're going to sign this particular transaction using a wallet address. So let me use a different wallet address so that we don't sort of create some confusion while going through this. So I just added another command within my call.sh script file. And in this case, we're going to increment the value from 0 to 1. That is what we expect to happen by calling this particular function. Then afterwards, it should display to us the current value right here. Okay, so let's see what that is going to do. Missing required account ID. Okay, what did I pass in? I thought I just passed that. Oh, account ID. Sorry, guys, for that. Let's call this again and see what that is going to give us. Okay, awesome. So that just gave us the value 1. Why? After incrementing the value from 0, so the current value is 1. And if you're able to run that from your end, guys, you should be able to get 1 as per now, unless you're going to increment it from your end, that is. Okay. So that is basically how we go about that. So we can increment the value again so that we have 2. Then we try and decrement and see what happens. So I just executed our call script again. So that should increment the value from 1 to 2. And that is exactly what happened. And if I go ahead and comment that command out in our call script file, and now execute the command that is basically going to read the value, we should be able to get the value 2. Okay. So let's run that and see what comes. So you realize we get the value 2. Okay, guys. So let's try and now decrement this value. Okay. Let's see how we can decrement the value. So in this case, we're basically going to call the function decrement. So the function decrement is here, and it is basically going to decrement our value. So after running this, we expect that to be 1. Okay. We expect our value to be 1, so that it will have been decremented from the. So here is the value. So our value is apparently 1. So guys, that is basically how you go about smart contract writing, or doing a smart contract source code in Rust and deploying it on the near blockchain. So this is a very basic smart contract. In this case, we're talking about. Now, I'll just, if there's any question, please put up your hand or put it in the chat so that I don't leave you out at any point in time during this session. So Destiny, you have a question? Yes.
Okay, sir. Can you hear me, sir?
Yeah, I can get you.
Okay, this deploy that's the script. You said you allow it to deploy. Or I don't understand how you said it by initializing a general command for it to be able to deploy or run script. I don't understand that place, which you put out a command, so CHOM, then I think the script, then start, something like that. Are you getting what I'm saying? Okay. So, uh, uh,
Oh,
so the
sorry, guys. I think I was just talking while muted. I'm really sorry.
oh,
Sorry, guys. I was just talking while muted. So I'll just repeat what I did. So I said, to respond to your question, Destiny,
yes, sir.
I went ahead and created a try script file. So
Yeah,
try.sh file, right?
yes,
Then I basically copied the contents of our call script to it.
yes.
So this qualifies it to be a script file, the first statement. Now, like I said, I was going to try to execute it from my terminal without first granting it permission to do so. Okay. And that is what I definitely did from my terminal right here. And the response was that the file has no
Denied.
permission. Yeah. So it had no permission to be executed as a script file. So it's some sort of Linux security issues if you're
Okay.
operating from Linux. But if you're on Windows, you can use bat files. So I think Windows, if you're on Windows, this is how you do. This is how you do this. So you do try.bat file, okay? But since I'm on Linux, I'm using .sh. So the file extension is different right there. Please take note of that. Yeah.
Okay, so on Windows, how do we give it permission? Is it that same way? Besides those commands, is it like the name of the root folders or is something different?
Okay, this command is this is a Linux command, change mode. I think that is the full name, change mode. Then these numbers, they also have some description behind them, so they hold some description. I'll be looking for some resources related to these guys, and I'll share with us for us to read extensively. But if you're on Windows, what I know is this is how you'd sort of write your file. But then granting it permission, I'm not quite sure. I am not quite sure unless someone wants to help us on this. Samuel, you have a solution? I really have no idea how to grant it a permission.
Very important.
Yes? Destiny?
I say it's very important.
Yeah.
I can hear you, sir. Can you hear me, sir?
Yeah, I can get you.
It's very important, and I will start asking my questions now, pointing it direct to what I'm using. I'm using a Windows. I'm using Windows 10 operating system. So
Okay.
I noticed some of these things are different in operation here and out there. Like for me to run the L world, for me to compile and run the L world code I wrote, which wasn't that easy. Touch didn't work here. So I have to manually do it, and still it didn't work. I have to use cargo direct. That's how it worked. So I've been wanting to ask before which operation system you are using, but it's clear now. It's clear now. So let's get help now. Anybody help us, I beg.
Yeah, sure. Yeah, please, if you have any solution, please bring it up. Samuel, your hand is up. Samuel again. You can just unmute. Okay, while Samuel does that, Cosmas.
I have a question as far as we had a meeting the other day about pitching.
Yeah.
That thing about ideas, do you have ideas? I have a question about that. Can I ask about that?
Okay, just hold, and I'll give you a chance, please, as we come to the close of this session. Do you mind, please? Cosmos?
Okay.
Yeah. Just hold on. I'll get back to you. Samson?
Hello.
Hello.
Okay, so I think there are two options for the guy on Windows. I think the first one is you can just right-click and run as administrator. I think that will give the script every permission it needs. And I think by now you should have Git installed. So if he's using VS Code, if you can use Bash, and like if you like on VS Code selecting you can illustrate it. When you click the drop down, like where Bash is written, you can select other types of shells. Down there, yeah. You can click there, then they drop down to the right of Bash after the plus.
Okay, here.
Yeah. Maybe you can use Bash now so that you can follow along what you do. You can just create the scripts in Linux, then you can execute using Bash. You can just save with the .sh file and it can run on Windows.
Oh, so this can work. So Destiny, I really hope you've got that. So you can simply launch your terminal. Yes?
With what you say now, .sh can as well work on Windows, right?
Yeah,
Yeah,
I think by now you have installed Git, and when you're installing Git, you also install Git bash. So you can run .sh files from Windows.
Yeah, because some time ago I gave my PC full permission to run script. I think it was when I wanted to use Yarn. I wanted to use Yarn on React, on the React dashboard I was working on. So I wanted to use Yarn on it. So that's why I gave my PC the authority to run script in general. So I don't know if I still have to give it manual permission with this. I'm not my PC. I've not been following the class with my PC, but offline I do run my practical and so on and so forth. I will give you guys updates on how everything will go through.
Awesome. I think you'll appreciate that. So thank you so much, Samson, for that clarity. Okay, Samuel, if you're back, maybe you can just unmute and put up your question. Samuel. Okay, seems you still have issues. Once you're ready, just let me know. Okay. Now, guys, we're going to talk. Time is almost gone, and I really didn't want us to go before we look at these. So let me just share this first. Should be this, right? Yeah. So we are here, and I wanted us to talk about some of the things or some of the functions that are available to you as a developer that are particularly blockchain specific on the NEAR protocol blockchain. So in this case, we're going to look at, we're going to Google for NEAR docs in this case. So if we Google NEAR docs and click on the first link, getting started, more documentation.
Hello. Oh.
Sorry for that. Yeah, NEAR documentation. Then right here, I'm going to navigate to smart contract. Under smart contract, there's another subtopic Rust, then Rust SDK. So Rust SDK, right here, if you read through all these, you're going to get some more information. And I'm going to share with us these in the chat. So if you have time, please, sorry, if you have time, just go ahead and read through. So for now, we're going to look at, there's a link that has been availed right here for the NEAR SDK, a Rust package for NEAR SDK. So right here, no, not this one, sorry. I think it should be this. So let us just try opening that in a new tab. Not this either. Shouldn't be this one. If I can get here, okay. So what I was looking for is there's a Rust package I'm looking for. Let me see if I can. I think I opened it earlier. Let's see if we can just find it. Right away. Okay. So I'll share this with us. So yeah, here's the link I was talking about. So I'll just put this in the chat as well for you to be able to go through it. Now, we're going to go. Now, this particular site gives us a list of all functions we can invoke from the ENV module. Now, ENV module, basically, I think it's elaborated right here. Blockchain specific methods available to the smart contract. In this case, the smart contract you're going to build. And it's up around some low-level blockchain interface. You know what you're doing, prefer using. Okay, This is basically how you can import it. That is what they're talking about right there. So if you're coming from, like, I mean, if you have some experience with the blockchain programming, like Ethereum environment, there's this concept of context. There's the context concept. Guys, I hope I'm not confusing. I'm not confusing. So in NIA, particularly Rust programming language, the context concept is presented to us through this env module. And so using it, we are able to perform a series of operations while we invoke these functions available to us. So the very first thing we can do is check or see whoever is signing this transaction, whatever wallet address is signing this transaction, how much tokens they've attached to a transaction, and very many other functions. So I'm simply going to talk about few because time is already gone. So I'll just talk about few, update them in our smart contract, and see how we can invoke the rest later. So right here in our smart contract, our counter smart contract, I'm just going to add some weird functions to it. So the very first function I'm going to add is a function that is going to display to us whoever is signing this transaction. So whatever wallet address is that is signing this particular transaction. And how do we do that? Okay, let me call this signer. And signer is also going to be a member method of this particular class. And it is basically going to return a string. Okay, so in this case, a string. Now, for us to be able to get the wallet address that is signing this particular transaction, we're going to use the env module available to us from the NIA SDK. And we're basically going to import it in. So I just imported it right here from the NIA SDK. Then I'm going to invoke signer account ID. And that is basically what I'm going to return. So this is how we get the wallet address that is signing our transaction, or I can just as well call it wallet address. Okay. So this is our last round of this session, guys. Let's just be patient. So that is the wallet address. The other thing we can do is check any amount that is now, guys. Maybe something to note for those of us who are looking forward to work into real projects. Any function that is going to utilize any of this module, the env module, it's by default going to be a call function. Okay, because in this case you're sort of doing more than the read operations. Okay, so just know that anywhere you're going to use this particular module, it automatically or by default makes that function a call function. So you'll have to sign that function while calling it. Now, this one we're going to call, okay, we're going to check if there's any attached deposit, any deposit attached, or any token, NIA token in this case, attached to this particular transaction. So we can call these attached NIA. Okay, I'm just running short of names. So attached NIA is going to return a value of type U128, and we're going to as well get this from our env module by checking for attached deposit. So that's how we go about that. And for us to be able to attach any token while invoking any function of our smart contract, then we'll have to explicitly define within our smart contract that whatever function we are calling accepts some NIA tokens. And a macro has been availed to us. It's called payable by the NIA. So if you're going to do a function that is basically going to accept some NIA tokens attached to it, then you'll have to use this macro within your smart contract. So please take key note of that. We're also going to check the amount of gas used. I think this one is also can come in handy. So we can just call these gas. Okay, let's call this gas because we're going to return quite a bunch of information here. Then we're going to do, or we're going to return, I hope we can return a tuple of type U128 and U128. I really hope we can do that. So that right here, we first of all get the attached gas, okay? That is the gas that was attached to this particular transaction. In this case, we can get that by doing env attached. Okay, gas, prepaid gas. So that is the function. Then we can define another variable for gas used, right? Gas used. And these can be found by, yeah, doing that. So now that we have these values, we basically can return them back as attached gas and gas used. I really hope this can work, please. Okay, mismatch type, expected this, but then found that. Okay, so I think we need to change this to, we need to change the data type. How about this? So this is also a U64. So U64, awesome. So we should be good to go. So guys, for now, just allow me show you these three functions and see how we're going to go about them. So now in this case, we're going to build, deploy, and try, calling this particular method we just added to our smart contract. Okay. Now I'll just go ahead and run our build script. And there's a mistake I've made, guys. While I made this a member function to this class, I think the rest were, I ignored the rest. So that is the only change I made there. So I'll rebuild this again. This guy is giving us an error. Okay, this must be mutable, so can just do that for now. That should be good to go. So I'll just redo this for the sake of the changes I just made so that we have everything reflected. That went right. Then I'm going to deploy. So I'm going to run our deploy script, right? Let me run our deploy script over there. So that should be able to deploy our smart contract. So that was done deploying. Then let's try run, sorry. Let's try running our call script to see if everything went well. So I'll just read a value. Just read a value from that contract. This should give us 0 or some. So that just worked well. So I'm simply going to invoke the functions, the three functions I just added. That is, let's start with the wallet address function of our smart contract. So this should give us the wallet address of whoever is signing this transaction or whoever is invoking this function in our smart contract. Okay. Now to do that, I'll just comment that out for now, then do this down here. So we're going to do a near call. In this case, test.wajakoya.testnet is where we deployed our smart contract. And we're going to call wallet address function. However, we have to sign this particular transaction. So to do that, we indicate that by passing our or the account ID that is going to sign this particular transaction. So I'm going to use yto.testnet. And like I said, this is a wallet address I already logged into from my terminal. So I'll just redo that and let's see what will be displayed to us. Awesome. So you realize yto.testnet is the wallet address that signed this particular transaction. We can as well try a different wallet address as long as we've logged into it from our terminal. So in this case, I'm doing wajakoya.testnet. Let's see what that will display to us. So it should display wajakoya.testnet. Awesome. So that is exactly what happened. Okay. So that is it about our wallet address function. The other function we added is a payable function. So in this case, attached near. So I'll first of all run it without attaching any near token to it. So just as it is, let's see what this will give us. Okay. I think it should give us 0 because there's nothing we've attached. Awesome. So that just responded with a 0. Okay. What if we wanted to attach some near tokens to this? How do we do that from our terminal? Now, take key note on this. So other than the account ID parameter I just passed, I'm going to add another called amount. And the amount is going to take value 2. So in this case, I'm going to attach 2 near tokens. Okay. So by running this function again, we expect it to display to us the attached near tokens. In this case, the value 2. Let's see what that will give us if we do that again. Okay. This one is telling us that the amount is unknown. So I think we passed the wrong parameter. So there's amount. Oh, I think it was misspelling in my parameter name. So let's put these again and see what this gives us. Awesome. Now, a value is returned to us, but then it's formatted in a different way. Now, while storing, I think I should just mention this right here. While storing near tokens, they are converted into what we call Yocto near. So Yocto near is basically, this is how the conversion happens. So 1 near is equivalent to 10 to the power of 24 Yocto near. Okay, so this is basically the conversion. So this is 1 near. Yeah, so this is the conversion. So 1 near is equivalent to 10 to power 24 Yocto near. So in our case, we passed 2 nears. And that's why you can see the value that is returned to us down here. So it's 2 times 10 to power 24. Guys, I really hope that made sense to us, right? And I didn't confuse anyone. So that is basically how we can read any attached deposit to any function call you're going to implement within your smart contract. Now, this comes handy if you have some functions that you want the users or whoever is going to invoke it to sort of make some payment. We'll be looking at that in a staking storage or storage staking topic, as we shall be looking at that. As we shall be covering it. So at this point, I'll cover our third function, or our newly added third function, this one right here. So we called it gas. So this is basically going to display the amount of gas we attached to this particular transaction, how many, and the value of that amount we attached that was used. So basically the amount of gas we attached and the amount of gas that was used. That will be returned to us in form of a tuple. So let's change that to the value gas. So I'll just do away with the amount for now, guys. Then just run it as it is. So I prefer going with the defaults first before we make any change to our parameter. So I'll run that script again. Awesome. So you realize that an object has been returned to us. This looks like an array, right? So the very first item is the amount of gas we attached. So in this case, we attached 3. This should be 3 teragas. I'm not wrong. These should be 3 teragas. And out of these 3 teragas, this is the amount of gas that was used to perform this operation. Okay. So any transaction you're going to perform on a blockchain, in this case, on the NEAR protocol blockchain, you have to pay for it, or rather there are some charges attached to that particular transaction. And this is why if you've been on the blockchain news, you must have heard that it's very expensive to perform machine learning tasks on blockchain. So this is where the catch comes in, because you have to pay for that particular transaction. And there are a lot of factors that comes into play while calculating that value. The IO operations, the network bandwidth, and very many other parameters or factors that are considered in order to arrive to these costs. Now, if you're going to run a machine learning or you're going to do some artificial intelligence related tasks on blockchain, then it's really going to be expensive for you, okay? And even if you are to spoof, we call it spoofing or denial of attack by any attacker to a smart contract, before you realize, you'll be out of funds. If you are the attacker, you'll be out of funds. And that's why they say that security is really hardened on a blockchain network. So these are some of the parameters or factors that sort of strengthens a blockchain security for to your software or to your smart contract. So that is it. Now, I'm simply going to run this particular command again, but then I'm going to specify the amount of gas I'm going to attach, okay? So to do that, I just pass the parameter, the gas parameter, then I specify the value. Now, a teragas takes 4 3 zeros, or it takes 12 zeros, okay? So that's what a teragas means. So in this case, I'm going to attach 7 teragas. So 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so 7 teragas, that is the amount of gas I'm going to attach. Then I'll run this again. So I expect the first value in that array that is going to be returned to be 7 teragas. And this is what you can see right here, guys. So this is the amount of gas we attached, and out of it, this is what was used, or the amount of gas that was used. You realize it is less. And compared to Ethereum, this is way less than what Ethereum network charges for their transactions. If you're an Ethereum developer, you can maybe you can just confirm that to us. So NEAR is quite affordable, if I may say, for the smart contract transactions. So guys, that is basically, or those are some of the simple operations we can do on a NEAR protocol blockchain. But then I hope I shared that link with you. Yeah, please follow that link and read more on the kind of operations you can do using the ENV module, in this case, the context concept on our NEAR protocol blockchain using Rust programming language. Yeah, so that is what I wanted us to cover today. I know we've not covered extensively the list I presented to us in our slide, the functions I was talking about. So maybe you can do that on your own as an assignment. So go ahead and this is basically how you're going to invoke those functions, env, and then the function name. And ensure you import the env module from the NEAR SDK as illustrated up here, so that you don't run into errors. And yeah, you'll be good to go. So that should be able to prepare you for some very big things you're going to work on in our coming sessions. Now, that marks the end of this particular session. Tomorrow, we'll be talking about storage persistent storage, in this case, on the near blockchain, and how we can implement that or how we can go about that. Then Friday, we will be presenting or walking through our project. Now, you remember the project we did yesterday or in our previous session? I'll simply set it on the near protocol blockchain. So basically what we implemented in our previous sessions, I'll basically use that project. We called it wish list. So it was our car wish list. So I'll basically set that on the near protocol blockchain, then walk through how we went about the implementation to give you an idea how you can implement your project you're working on. That is the simple banking system I told you guys to work on. So how you can basically set it on the near protocol blockchain network as a smart contract and see how things are going to unveil. So that is basically what we'll be covering this week. Next week, we'll talk about front end. So we'll first talk about storage staking and cross-contract call concepts. And then we talk about front end and then fungible tokens. So that will be our last topic, fungible tokens. So guys, that is it. Is there any question from anyone? Yes, Destiny.
Okay, thank you, sir. Actually, I had from the past. One, you just talk about it now. That's that project.
Yeah.
Assignment. I've not done it, though I've got logic to do it, but implementing it on Rust is something I've not fully balanced on, but I will work on it this night. But I'm finding it hard to understand Strut. I need light. Understanding Strut.
Okay.
On Strut so that I will understand it, because it's just like the ultimate of doing that thing. And among everything, is the only one I don't understand. Then the next other one is the project you showed, the one you create, the wish list.
Yeah.
If possible, you can go across it again like the way you did that time. I'll be so grateful. Those are just the two things only.
If I can, sorry, I didn't get your last point. Disney, I didn't get your last point. You're talking about me, I don't know, demonstrating the wish list project.
Yes.
Okay. So
the day you did it. Okay, I'm listening.
Okay, I'll be doing that in our coming session. So before I show us its version on blockchain, I'll simply walk us through its version on the normal Rust, as a normal Rust program, right? I think that should work. Okay.
Yes, that would be great. Great.
Okay.
Then.
Okay, that's awesome. So that is there any other question from anyone? I'll be showing us the two versions during that session. So let's just wait for it. Anyone with any other concern? Is there anyone? Samuel, are you back? Samuel Agea. Samuel Agea, maybe you can just unmute and raise your concern.
Sir, I have another. I want to ask.
Yes.
This files here. So automatically, when we run that command,
Destiny, I think. Okay.
Have all.
Destiny, you're breaking. Your network is really shaky.
Hello, sir. Can you hear me?
Yeah, I can get you now.
Okay. I said this file here. So run create near app on our command line, we actually have this file.
Hello.
Like and the file.
Hello, Destiny. I don't know, but your network is really shaky. I can't get what you're saying clearly.
Hello, can you hear me now?
Yeah.
Hello.
Yeah. Hello. Yeah, you can go ahead now.
Okay. Once we run the command, the create new app command on our terminal,
Yeah.
we are going to automatically have this file in computer.
Yes. Yes.
Because I'm asking this, after running the command and after you going through this file, over here you saying you want to open the code editor same file. That's why I'm asking.
Okay. Maybe just let me just respond to that. So I don't know if you can do this from this point. Let me try. Let me give it a try. Okay, so I just opened up our parent folder, our parent project folder, and that is what I'm going to share. So all this time we've been working from our contract folder, but then the project we created was demo, right? So demo. This is the project name we used, and by running npx create near app, all these files were created out of the box for us. Okay, so I said, instead of us looking at the whole of these files while working on our smart contracts, I just decided to sort of navigate to the contract folder. So this is the folder we've been working from all that time. And you can, as you can see, we have all our script files right there. We have our WASM binary files over there. And we also have our smart contract source code right there. So what I did is I basically opened up this particular folder and left the rest out. All these, I left all that out, and I just focused on this particular directory. Destiny, are you?
Good to ask.
You're good, yeah?
Hello?
Hello?
I am good. I'm good.
Okay.
Yeah. Remaining the structs. Last one. No, I told you I do not understand the structs. That's more.
Okay. Now, the struct concept. Okay, this is basically a Rust primitive. And there's a book I shared with us in our dev community, and maybe I should do that again before maybe we close. So let me just share this link with us so that if you're not in our dev community, maybe you can just join there. I'm going to share the book again, right, in the group. So let me do this, copy the link. If this can work, please.